while our technician was working on the machine, we were doing an in-depth Super Bowl, what number was it? 80, Super Bowl 80, which occurred yesterday. Unfortunately, due to technical difficulties, we cannot bring that to you. So we'll go back to calculus. Questions about that?
Is there a different way to set it up? Like if you want to do it with respect to y?
You got to go by all of these directions. That's a real good question. I'm going to give you one that says do it with respect to y, but in volume problems, at least until you get to Cal 4, in volume problems, you're going to be rotating around something. And it will tell you what to rotate around. And in this one, it says rotate it around the x-axis.
Well, it said the y-axis when you do it.
I hope it didn't.
It just seems like it'd be
Oh,
easy.
you mean if it said the y-axis, then we'd do the same thing we just did a minute ago with the area, wouldn't we? We would swap our x's and y's, huh? And we're going to work something like that.
It'd be like 1 minus to make sure you are getting.
You would solve this equation in terms of x, which means you would have x equal. So wouldn't this equation be x equal y squared?
Yeah.
And then you would do the same kind of thing, only you would do it with respect to the y-axis. As a rule, I never do them with respect to the y-axis unless I'm told to, because like you, I learned how to do it with respect to the x-axis, huh? But the problem itself is going to tell you. And that's going to be your problem with 6-1, is setting it up. Because again, the integration was nothing, right? Okay, let's do another one. This is example 5 on page, I don't want to do example 5. I want to do example 6. This is example 6. Page 336, example 6. And it is, I want to have y equal the square root of x. Have you ever seen that before? And the lines bounded by, this bounded by is what gives us the area of the base, doesn't it? Everybody agree? Bounded by y equal 1. Isn't that a line through 1 on the y-axis? Okay. X equal 4. Isn't that a line through 4 on the x-axis? About and rotated about y equal 1. I say, What they're saying is, isn't that the same problem? Right? Only, aren't they cutting it off at y equal 1? And then aren't they rotating it?
That makes it a little easier, doesn't it?
Well, I don't know. It's sort of easier is in the eye of the beholder, huh? Let's set it up and we'll take a look at it. This is 610 on 367. Isn't this the exact problem we just worked? And what they said, remember they said in between y equal 1 and x equal 4. it has to be above y equal 1 and to the left of x equal 4, huh? Everybody agree? Everybody agree? So what I'm going to do is I'm going to take a saw and I'm going to cut this thing off right about here all the way across. And I'm still going to rotate it, but I'm only going to rotate that much of it. So wouldn't the area of the base now be this cut off portion right here? Does everybody agree? Okay. So what we're going to do is, and now instead of rotating it about the x-axis, which is what we did earlier, now I'm going to rotate it about the line y equal 1. Now, here's the first thing I need to do is find the area of the base, right? And the area of the base is that on the end, isn't it? Agreed? So, I think what I've got to do now is now I have a circle. It's still a circle, isn't it? You agree? But the radius of this circle is right there, is it not? And at every slice, it's right there, huh? But here's what I want to know. How do you get that? And the way you do it is, you go all the way up to the top curve. Wouldn't that give you that blue line right there? Everybody agree? But I need to throw away this much of it, don't I? Agreed? So then, subtract the bottom boundary. And you tell me, is that not f of x minus f of x, just like we've been doing in area? Is that right? When we have two areas, didn't we go to the top one and subtract the bottom one from it? And that gives us that pink area right there. Everybody follow? This is one of those moments where you got to know what I'm doing or you're going to be dead in the water from here on. Everybody follow? So, Elijah?
You see, they subtract the f of x from the small, the little f of x. Right.
That's right. I go to the big f of x, and then I subtract little f of x, just like we would do when we were finding area. Why is it just like we would do when we're finding area? Because we are finding the area. Isn't this just an area problem? Everybody agree? Okay, so doesn't that mean that our R, the radius equal to big F minus little f, which is square root of x minus 1. Everybody agree? So, now don't I know the area of the base? Isn't that pi r squared? Is that right? Which is pi times square root of x minus 1 squared. Is that right? But isn't that pi times x minus 2 square root of x plus 1? I just squared that. How do you square a binomial? Yeah, just FOIL. And the shortcut for FOIL is the one I use all the time. Square the first term, square the last term, multiply the two together, times 2. This is F, this is L, and this is I and O put together. Yes?
Why did you bother doing that instead of using substitution and taking integral?
Instead of,
Well, like what we would normally do, just set the square root of x minus 1 equal to u or r, and then integrate it, and then plug your equation back in. Why bother removing the square?
we might have to do that in a minute. We might have to do that. Sometimes you have to do that. That's called a translation of the axis. You're in effect picking the origin up and moving it. What I always do is I try to avoid that step if I can, because sometimes when you square it, you make a pretty easy problem, which is what we did. And then if I have to do a substitution to integrate it, then I do. But I wait until I have to.
Okay.
Okay? All right?
What was that? You said square first term, square last term?
Square the first term. The square root of x squared is x. Square the last term, a minus 1 times a minus 1 is plus 1. And then multiply the two together, that's I and O, isn't it? Times 2.
Of what you got? Like multiply the ones that you just...
The ones on the end, multiply them together times 2. This is a good place to stop. I've run out of time. We'll finish this. Are you okay up until now? Okay. Thomas warned you.